Your coding agent receives build a payment system and immediately creates 12 files. It has skipped the unglamorous steps, understanding the product, defining boundaries, choosing tools, preserving state, and proving the result. These 5 GitHub repositories address those missing layers. They are not 5 versions of the same agent. Each solves a different workflow problem. Repository 1 is GitHub Spec Kit. Spec Kit centers the workflow on intent. Its default path moves from specification to plan, tasks, and implementation. Instead of asking an agent to transform one paragraph directly into a codebase, it creates reviewable artifacts between the idea and the edits. Use case: add team invitations to a software product. Observable example: the specification defines who can invite, expiration behavior, duplicate invitations, audit requirements, and acceptance tests. The plan maps those behaviors to the existing authentication and email systems. Only then does the task list name files. Limitation: a detailed process can be too heavy for a 2-line fix, and a beautifully formatted specification can still encode the wrong product decision. Use Spec Kit when ambiguity and cross-team agreement cost more than the ceremony. Repository 2 is Obra Superpowers. Superpowers is an agentic skills framework plus a strongly opinionated development methodology. It emphasizes brainstorming, detailed plans, test-driven development, systematic debugging, review and verification before completion. Use case: hand an agent a medium feature while preventing it from jumping directly into code. Observable example: the agent refines the design, writes a plan with exact files and tests, implements a small task, runs the failing test before the fix, then receives a separate review. Limitation: disciplined workflows consume time and tokens. Applying the full method to every tiny edit can turn a typo into a constitutional convention. Decision: use superpowers when process drift is the failure you repeatedly see, and the task is large enough to repay the overhead. Repository 3 is Model Context Protocol Servers. The MCP Servers repository contains reference server implementations that demonstrate how agents can reach tools and resources through a shared protocol. Use case: let a coding agent inspect an issue tracker and documentation without building a custom integration into every model client. Observable example: the agent lists approved resources, reads one issue, retrieves the relevant design document, and passes the evidence into its plan. The integration boundary remains explicit instead of hiding credentials inside a prompt. Limitation: a protocol standardizes connection shape, not trust. A server may expose excessive authority, return hostile content, or implement tools poorly. Reference servers are educational starting points, not automatic production approval. Decision: use MCP when several agent clients need the same controlled tool boundary, then audit every exposed action. Repository 4 is LangGraph. LangGraph models an agent workflow as a stateful graph. Nodes perform work, edges define transitions, and durable state can support interruption, resumption, and human checkpoints. Use case: build a code review agent that gathers context, proposes findings, requests approval for fixes, applies selected changes, and verifies them. Observable example: a failed test routes back to diagnosis, a sensitive change routes to human review. A process restart resumes from stored state instead of asking the model to remember the entire afternoon. Limitation: graphs can become complicated. If the workflow is 3 deterministic steps, a normal function may be clearer and easier to debug. Decision: use LangGraph when state, branching, recovery, and checkpoints are essential, not because boxes and arrows feel enterprise-ready. Repository 5 is Microsoft AutoGen. AutoGen provides abstractions for agentic applications, including agents, messages, tools, and multi-agent orchestration. Use case: separate a migration into an implementer, test analyst, and reviewer with different tool scopes. Observable example: the implementer changes only the assigned package. The test analyst runs and interprets the suite. The reviewer compares the diff with the requirement and rejects scope expansion. Limitation: multiple agents multiply coordination, cost, and opportunities for inconsistent state. 3 model personas do not automatically equal 1 experienced engineering team. Decision: use AutoGen when roles have genuinely different context or authority and their outputs can be integrated through clear contracts. Now assemble the map. Spec Kit defines what should be built. Superpowers disciplines how work progresses. MCP connects the agent to approved capabilities. LangGraph preserves state and routes the workflow. AutoGen coordinates distinct agent roles. You probably do not need all 5. Here's what one feature looks like when those layers cooperate without becoming framework soup. The product request is allow an administrator to invite a teammate by email. Spec Kit turns that sentence into behavior. Who may invite? Does an invitation expire? What happens when the email already belongs to a member? Which event enters the audit log? The specification makes those decisions visible before an agent guesses them inside code. Superpowers turns the approved behavior into an execution sequence. First, inspect the existing membership model, then write the failing expiration test, then implement the smallest path, then run the focused suite and request review. Its contribution is not another product decision. It is keeping the implementation honest. An MCP server can expose the approved issue, architecture note, and test environment. It should not expose every private document and a production database simply because the protocol permits tools. The server advertises narrow resources, validates inputs, and returns receipts. LangGraph becomes useful only if this job must survive interruption. The graph can checkpoint after the specification is approved, pause before an external email is sent, and resume at verification after a process restart. If the whole feature is completed in one deterministic command, leave the graph out. AutoGen earns a place only when role separation changes authority. An implementer can edit the membership package. A security reviewer can read the diff and tests but cannot write. A release agent can prepare a changelog but cannot deploy. If every agent sees the same context and calls the same tools, their different job titles are theater. Before inviting any repository into a real codebase, perform a small trust audit. Read the license and recent releases. Inspect installation scripts and transitive dependencies. Check whether the project is actively maintained, but do not confuse stars with maintenance. Identify what data leaves the machine, which commands can execute, and where credentials are stored. Pin a version for the experiment so tomorrow's result is comparable with today's. Then create a workflow receipt. Record the requirement version, repository versions, model, approved tools, files changed, tests run, human interventions, elapsed time, and final outcome. That receipt lets you compare a plain coding agent against the new mechanism instead of deciding from vibes. The strongest stack is often only 2 layers. A small team with unclear requirements may need Spec Kit plus Superpowers. A long-running internal agent may need MCP plus LangGraph. A large migration with distinct authority might justify AutoGen, but only after the single-agent version exposes a real coordination limit. Run the experiment against one boring control, the same model, repository, tools, and task, with none of these frameworks. Compare requirement errors, escaped defects, human interventions, tokens, elapsed time, and recovery after interruption. If a new layer produces nicer artifacts but no better outcome, remove it. Workflow software must earn its maintenance cost with evidence. Start from the failure in your current system. If agents misunderstand requirements, add specification. If they skip tests, add execution discipline. If integrations are duplicated, standardize the tool boundary. If long tasks lose state, add durable orchestration. If one context is overloaded, consider separated roles. Install the smallest mechanism that fixes the measured problem. Run it on a representative task. Record success, latency, tokens, intervention, and escape defects. The goal is not to collect agent frameworks like browser tabs. The goal is a workflow where intent survives planning, actions remain controlled, state is recoverable, and completion is